Hello students, welcome to the second video on IoT Network Architecture and Design. Myself, Nita Chaudhary, working as Assistant Professor in Department of Information Technology at KKWIRR, Nashik. Now imagine a situation, one day you have decided to build a beautiful house. For the same, you drive to a shop where you decided to brought everything whatever is needed, like a screw, then a material to build cement mixture, then you build a metal material, whatever is required to build a beautiful house. And you reach to the place where you decided to build a beautiful house. Whatever you have purchased at that shop, that all the materials are now available at your place. But now, what's the thing? You don't have an architecture plan for the new house. Now what? So, here comes the importance of architecture plan for building a new house. Without that, you can't build a beautiful house. So, to successfully complete a construction project, time and efforts are required to design each phase from foundation to the roof. I cannot go further if my plan is not level at the micro level. I need to do the planning at the micro level. Then only then I can build a beautiful house. A strong architecture blueprints are necessary in all construction projects, from simple to very complex one. So here we have seen a simple example how the architecture plan is needed for building a beautiful house. Now you might be thinking why we are discussing the architecture plan of a building. Are we going to build a house? No, we are not going to build a house. Rather, we are seeing the importance of architecture plan, architecture blueprint, which is necessary in each and every phase. In the same vein, a computer network should never be built without a careful planning throughout a security policy, adherence to well understood design principles or practices. Failure to carefully architect a network according to sound a design principle will likely result in something that is difficult to scale, adapt to organization change, and worst of all, troubleshoot when things go wrong. If a network fails, a company operation can be seriously impaired, just as a house must be designed with a strength to withstand a potential natural disaster such as the any event which unnatural can occur. IT, that is nothing but information technology system, need to be designed to withstand a network earthquakes. Now, what can be those network earthquakes? Such as the DDoS, nothing but distributed denial of services attack, future growth requirement, network outage, or even a human error. Now, to address all these challenges, the art of network architecture has gained a tremendous influence in a IT organization from the last 2 decades. In the last 2 slides at the beginning, we have seen the importance of architecture plan, a micro level architecture plan which is required for build a beautiful house as well as to build a IT network. In this particular, we are going to focus on the IoT network architecture. Now, enterprise IT network architecture has matured significantly over the last 2 decades. The discipline of IoT network architecture is new and requires a fresh perspective. Now, it is important to note that while some similarities between IT, that is stands for information technology, and IoT, nothing but Internet of Things architecture, do exist for the most part, the challenges and the requirements of IoT systems are radically different from those of the traditional IT networks. We should not get confused in these two requirements and these two architectures of IT architecture as well as the IoT architecture. So IT networks are primarily concerned with the infrastructure that transferred the flow of data regardless of the data type. So the difference between IT and IoT networks is much like the difference between the residential architecture and the stadium architecture. Both are different. The architecture plan which is required for any bungalow or any flat system, that is nothing but a residential architecture scheme, is completely different. That is what required for any mall or for any stadium architecture. So I think you might be getting why I am focusing the two networks. I want to show that those two networks are really different from each other. Now, the traditional network architecture for IT has served us well for many years. We have seen the IT networks everywhere. Okay, wherever you see, we will find the IT network. They are not well suited for the complex requirement of the IoT. So if you are thinking that whatever the network which is existing that we can use for the IoT, no, we can't use for the IoT. I can say that the key difference between the IT and the IoT is the data. Why so? Because the IT systems are mostly concerned with the reliable and continuous support of the business applications such as the email, your web, databases and the CRM system, like this kind of system. Whereas the IoT is all about the data generated by the sensors and how that data is used. We have seen this in the last one, in the first video, where we have seen the application of IoT. There are vast number of the data, that is what turned to be a big data, which is being generated by the IoT devices. The sensor data which is generated by the IoT devices is captured at every second. So these kind of a data is going to be generated by the IoT devices, right? And those kind of a data, how we are going to use that data is going to be concerned over here. So the essence of the IoT architecture thus involves how the data is transported, collected, analyzed, and ultimately how we are going to do or act on that one. So here we are going to see some of the key differences of the IT and the IoT. We'll start with the first one, and that is the first one as the scale. What is the challenge in front of us is nothing but the scale. So the massive scale of the IoT endpoints, that is nothing but a sensor, is far beyond than the typical IoT network. So this is nothing but the architecture challenges which are required in case of the IoT. The second challenge is about the security. IoT device, especially those on the WSN stands for wireless sensor networks, are often physically exposed to the world. So security is required at every level of the IoT network. And the third challenge is device and network constrained by power, CPU, memory and link speed. Now due to massive scale and a longer distance, the network are often constrained loosely, capable of supporting only minimal data rates. So these are the challenges can be considered as the key differences between the IT and the IoT network. I have taken the reference from the book IoT Fundamentals, Network Technologies, Protocols and Use Case for IoT, that is Internet of Things, by David Gonzola, Patrick Cisco Press. Thank you for listening. In the last segment of the video, we learned the importance of the architecture. Then we learned the difference between the IT and IoT architecture. In this particular segment of the video, we are going to learn on one M2M, that is machine-to-machine IoT Standardized Architecture. In an effort to standardize the rapidly growing field of machine-to-machine communication, that is M2M communication, the European Telecommunication Standard Institute, that is called as ETSI, created the M2M, that is Machine-to-Machine Technical Committee, in the year 2008. The goal of this committee was to create a common architecture that would help to accelerate the adoption of M2M application and the device. The scope has expanded to include the IoT, that is Internet of Things. One related body also began to create a similar M2M architecture, and common standard for M2M became necessary. Recognizing the need in the year 2012, ETSI, that is nothing but European Telecommunication Standard Institute, and the 13 other foundation members launched a One M2M as a global initiative designed to promote the efficient M2M communication system and IoT. Let's begin with the goal of One M2M. The goal of One M2M is to create a common service layer which can readily embedded in the field device to allow the communication with the application server. One M2M framework focus on IoT services, applications and platforms. These include the smart metering application, smart grid, smart city automation, e-health and connected vehicles. Now what we are going to see next are the greatest challenges in the design of an IoT architecture, as well as we have to look for the standardized IoT architecture. Now one of the greatest challenge is in designing an IoT architecture is dealing with the heterogeneity of device, software and access method. By developing a horizontal platform architecture, One M2M is developing standards that allow the interoperability at all the levels of the IoT stack. Now the next further, we are going to discuss one important example of automation of HAVOC. HAVOC stands for heating, ventilation and air conditioning system. Now imagine a situation that you might want to automate your HAVOC system, that is HVAC system, stands for heating, ventilation, air conditioning control system. By connecting it with the wireless temperature sensor spread throughout your office, because you want to control all the things. So what you did? So you decided to deploy a sensor that use LoRa WAN technology. LoRa WAN technology stands for Long Range Wide Area Network. Now the problem is that the LoRa WAN network and the BACnet stands for Building Automation and Control Network System, that your HAVOC and BMS run on are completely different systems and have no natural connection point between them. So this is where the One M2M common service architecture comes in. That's why the need comes that we need a different One M2M architecture, which will be common architecture, which will adopt all these changes. So One M2M horizontal framework and the RESTful stands for Representational State Transfer API allow the low range wide area system to interface with the building management system over an IoT network. So our motto of installing the HVAC system will come in a picture, because now we have come up with the solution that how we can do the end-to-end IoT communication with the system. So it promotes the end-to-end IoT communication in consistent way, no matter how heterogeneous the networks are. Now after discussing the challenges, let's talk about the main elements of the One M2M IoT architecture. So this is what the main elements of the one M2M IoT architecture. You can see the application layer, service layer and the network layer. Okay, so let's learn about this one in more detail. So the one M2M architecture divides the IoT functions in three major domains. The first one as the application layer, which can be the smart energy, asset tracking or a fleet management one. The second one as the service layer, nothing but the one M2M includes a common service horizontal framework which supports resultful API. That is what the output of this particular layer. And the third one as the network layer, which is nothing but the one which is application talk to a API to communicate to the server. This architecture is very rich and promotes the interoperability through the IT-friendly API and support a wide range of IT technology. Now, in the next section, we are going to discuss these layers in more detail. We'll start with the first layer as the application layer. The one M2M architecture gives a major attention to a connectivity between the devices and their application. This domain includes the application layer protocol, which aims to standardize the northbound API definition for interaction with the BI system. BI system stands for the Business Intelligence System. Applications tends to the industry specific or have their own set of data model. Thus, they are shown as a vertical entries in the diagram which we have just seen. The next one as the service layer. This layer is shown as the horizontal framework across the vertical industry application. At this layer, horizontal module includes the physical network that the IoT application runs on, the underlying management protocols and the hardware. So which examples may include the backhaul communication via cellular, the MPLS nothing but multi-protocol label switching network, VPN and so on. This conceptual layer adds an API and middleware supporting the third-party services and the application. Now, a critical objective of a one M2M is to attract and actively involve organizations from M2M related business domain, including the telematics and intelligent transportation, healthcare utilities and so on. The next layer as the network layer. This is the communication domain for IoT device and the endpoint. It includes the devices themselves and the communication network that links them. Examples include for the wireless mesh technologies such as IEEE 802.15.4, wireless point-to multi-point system such as IEEE 801.11ah, wired device connections such as IEEE 1901 power line communication. Now, in many cases, these smart devices communicate with each other. We have seen that the smart devices communicate with each other. In other cases, machine-to-machine communication is not necessary and the device simply communicates through the FAN, that is nothing but a field area network, to use case-specific apps in the IoT application domain. The device domain also includes the gateway devices. I have taken the reference from the book IoT Fundamentals, Network Technologies, Protocols and Use Case for IoT, that is Internet of Things, by David Gonzola, Patrick Cisco Press. Thank you for listening. In the last segment of the video, we discussed one machine-to-machine IoT standardized architecture. In this part of the video, we are going to discuss the IoT World Forum Standardized architecture. In 2014, the IoT World Forum Architecture Committee, which led by Cisco, IBM, Rockwell Automation and others, published a 7-layer IoT architecture reference model. While the various IoT reference models exist, the one put forth by the IoT World Forum offers a clean, simplified perspective on IoT and includes edge computing, data storage and access. It provides a concise way of visualizing the IoT from a technical perspective. Each of the 7 layers is broken down into specific functions. Security imposes the entire module. This is what the architecture which is put forth by the IoT World Forum. This IoT reference model defines a set of levels with control flowing from the center to the edge, which includes sensors, devices, machines, and other type of intelligent endpoint. In general, the data travels up the stack originating from the edge and goes northbound to the center. Using this reference model, we can able to achieve the following things. The first one is decomposes the IoT problem into smaller parts, identify different technologies at each layer and how they relate to each other, define a system in which different parts can be provided by different vendors, have a process of defining interface that link to interoperability, and define a tier security model that is enforced at transmission point between the layers. Now in the following section we are closely going to see each of these 7 layers of IoT reference model. We start with the first layer as the physical devices and the control layer. The first layer of IoT reference model is the physical device and controller layer. This layer is home to the things in Internet of Things, includes a various endpoint devices and a sensor that send and receive the information. The size of things can vary from almost microscope sensor to a giant machine in a factory. Their primary function is generating data and being capable of being queuing and controlling over the network. This is what about the first layer of the IoT reference model. Let's talk about the second layer as the connectivity layer. In the second layer of the IoT reference model, the focus is on the connectivity. The most important function of this layer is reliable and timely transmission of the data. More specifically, this includes transmission between layer 1 devices and network, and between the network and information processing that occurs in a layer 3. That is from layer 1 to layer 3. A connectivity layer occurs between these two. The connectivity layer encompasses all the networking element of the IoT. Now let's see the functionality of layer 2 in a concise format as the communication between layer 1 devices, reliable delivery of information across the network, switching and routing, translation between the protocols, and network layer security. Let's go with the third one as edge computing layer. Edge computing is the role of the layer 3. That's why it's named as. Edge computing is often referred to as the fog layer. At this layer, the emphasis is on the data reduction and converting the network data flow into information that is ready for storage and processing by the higher layer. One of the basic principles of this reference model is that information processing initiated as early and as close to the edge of the network as possible. A critical function is assessing the data to see if predefined thresholds are crossed and any action or alert need to be sent. So this is what the main functions to be performed by the layers. These are what the functions which are handled by the layer 3, which include evaluation and reformat data for processing at higher level, filter data to reduce traffic, higher level processing, assess data for alerting, notification and other action. Now for the upper layer, layer 4 to 7. The upper layer deals with handling and processing the IoT data generated by the bottom layers. Now the table summarizes the different functions of these layers. We'll see one by one. The fourth layer as the data, the fourth one layer as the data accumulation layer captures, it includes the functionality of this particular layer is to capture the data, store it so it is usable by the application whenever it is necessary, convert the event-based data to the query-based processing. Layer number 4 as the data abstraction layer, reconcile multiple data formats, ensures consistent semantic from the various sources, confirms that the data set is complete, consolidated that data into one place or multiple data stores using virtualization. Layer number 6 as the application layer, interpret the data using the software applications. Application may monitor, control, provide the report based on the analysis of the data. So analysis of the data is included in application layer, and the last layer as the collaboration and process layer, which consumes and share the application information. Collaborating on and communicating IoT information often requires a multiple steps, and it is what makes IoT useful. So this layer can change the business processes and delivers the benefits of the IoT layer. So thus in this section we discussed the all 7 layers of IoT reference model, which comes in a picture in the year 2014, which is put forward to us by the IoT World Forum Stand, which is consist of the 7 layers. I have taken the reference from the book IoT Fundamentals, Network Technologies, Protocols and Use Case for IoT, that is Internet of Things, by David Gonzola, Patrick Cisco Press. Thank you for listening.